Okay, the simple circuits are pretty much done, so I really can't do one circuit at a time anymore. So let me just draw out what needs to be done. We're gonna basically take just a jumper off of one, and we're gonna go to the cam side over here. We just call that A, B, and C. So we just use A and C like we did 1 and 3 on the other side. All right, so we're gonna go from A. We want to come off to the motor and come over here. I have the umbrella switch, which is normally closed switch. I just write that umbrella. It's a stupid name, but that's the name they gave it. Then we're going to go to a normally open cam switch, and then back to terminal C. And we're going to connect that from, just go right to here. So we got this motor in line. Now the problem with the motor is you're going to have to get it to turn on momentarily, and that's kind of hard to explain. Let me just draw all this first, then I'll go over all this. So let's see, we need coming off here. You don't know. You normally open a relay. Actually, that'll be the second switch, and that's going to come back over here. Then we have to come off here to the coin switch. Then we're going to go to the relay coil. Better circle. To normally closed cam switch. Oh, this is going to make sense when it's going to go back to C also. So this is normally closed cam. That's a coin. What else we need? We need one more switch in here. And this one is the normally open relay switch. Is the one out of 2 of them. Okay, then we need protection for the motor. So if there's a trouble, if it's getting too hot in there. Actually, it's not protection for the motor. It's protection for overheating, not the motor, but actually the machine itself. The smoke in the old house. So you need a safety here. This is a thermostat. It's a high temp safety. If there's not enough kernels in there and it doesn't lift up the umbrella switch, your popcorn is going to just burn and it's going to smoke up the whole house. And this one, we're actually going to take it back to 3. Okay, see, I'll have to wire it up a little bit at a time, and then I'll show you what I'm doing, and then I'll explain the whole thing. Okay, I'm going to try to whittle away at this a little bit at a time. So first thing I want to do is I want to bring power to the other side. So I'm going to go off of terminal 1, which is right here, you're hot, and terminal 3. And what I did was I came up through some of these porcelain insulators here and over here. And if you look, there's a metal trough. Well, let me turn it. Oh, jeez, there's a metal trough for the wires. So I got it going through. Coming through some more insulators and basically give me power on this side. And then the other thing I did was your high temp safety. I went from, as I was saying before, I'm going from 3. So this was 3. I went from 3. I went up to, actually, no, I'm getting lost here. It's this one here. Went over to here. It's just your common to one side of the switch, then out of the other side of the switch, as you see over here, it's going to come up and it's going to join up with the umbrella switch. The normally open relay is going to attach there. I could move that over here, and then the motor. So I just let that one bare right now. What we have here is just a little relay, and the reason we're using this is how do you explain this? Basically, the original one used a mercury switch instead of this relay. It was a much easier design. What they had was on the cam they had a mercury switch, and they had on this rod here. I don't know if you can make that out. There used to be a bar that would actually come over in the coin switch here. So when a coin would fall through and make the switch, this little rod will keep the coin from falling through, and the coin would keep pressure on this lever, which made the switch, and the switch stayed closed, and that would keep the motor running. And while the motor ran, the cam would turn, and when the cam turned, the mercury switch would tilt, and then the power would go from through there into here, so the motor would be working then off the mercury switch. And then what would happen is, as this cam turns, this lever would have moved, and then the lever would have moved away from here, and the coin would have dropped through. It was a lot easier that way, but they decided to go with this relay. So what you have to do is you have to figure out how to have the coin switch, which is going to be like a split second, because it's going to go in and it's going to go through. So you got, like, boom, it's done. So you got to drop the coin in, and it's going to have to make this relay. Okay, it's going to make the relay for like a second, just like that. Alright, well then the motor's going to start, it's going to work, and it's going to stop. So you have to keep this energized. So what you do is you have a normally open switch, and it goes to your coil here. So when the coin switch, not the switch, when the dime, makes a coin switch, sends power through here to the coil for that 1 second, and when that closes, it closes this normally open switch, making it closed now, and power is going through there back to the coil, and it keeps it energized. So that's how they get around that. Now the coil is going to stay energized, so what you have to do is you put a cam switch here, and then you have to have it in series with this coil, so as the motor starts turning, the switch, which is open and closed off of this, would reverse positions, and then it would just, the closed switch would open, killing this relay. But the open switch, which will close, keeps the motor running. So like I said, it's pretty complex. But anyway, what I did was I wired this up, just so it's a lot easier doing it here. And basically, like I said, I have the coil. So this wire here is going to go to the coin switch, and this one here is coming up to the normally open relay switch, and the normally open relay switch is going back to A. And then you have, let's see, what else do we have? The coil. It's going to come back through to the normally closed cam switch. Then we have this switch here, which is a normally open relay, and that's just coming off of the motor. This is a common off the motor, and that just goes through the switch and comes back to C. And I just hook this up, and then we'll go to the next step. To get to the umbrella switch, you're going to have to remove the cam, the gear, and the other cam, which just works this brass weight for the umbrella. That basically just, this is what opens and closes the switch to make the motor stop during the popping cycle. First you got to remove this top piece, basically this piece here, and then you have to remove these levers. There's screws and cotter pins in there, and then if you pull this down, the cam assembly slides out there. It's a little hard to show wire for wire when I'm doing this. When I get to this 2 circuits here, I got the relay circuit and the motor circuit. So you seen how I had the relay with the wires out, and I put it all in and ran all these wires and trimmed them up. So I'm just going to run through where the wires go. You got terminal A, and you got a hot wire coming off here. So I got that coming up here. It's going up to the coin switch. Okay, then I got a jumper from the coin switch to the normally open relay, and that comes over on this side. This is from the, let's see, which one is this? That's the normally open relay coming over here. And then we have the one from the coin switch. And that's this one here. And that's going to the coil, which is right here. You see it coming down. I'm sorry, this one here. And then you got this one here going to the same area. And that's just a jumper here from the normally open relay. From the switch to the coil. That's over here, coming down here. And then out of the coil, we're going up here through this trough, coming through all this, and that one's going to the normally closed, which is this top wire here, part of the cam switch. Then out of the cam switch, the common part is going back to terminal C. Now this normally closed cam switch and this normally open cam switch, I'm showing two wires. It's actually the same wire. It's this common right here. I just figured it was easier to draw it this way. Okay, so that's this circuit here. Okay, that was the relay circuit, so now I'm going to show you the motor circuit. It starts off with terminal A, which is right here. Brings a wire up to the motor, which is back here, you don't see it. Goes up to the motor, comes out. So it's basically here, goes through the motor. Now you get to this junction here. We got 4 wires. The reason I left this here is so they can put an inline fuse. You should have like a 10 amp inline fuse on the motor. So I just left this where they can take the wire out off and put what they want. Let's see, the first circuit, we're going to go up to the normally open relay switch. So it goes up through this trough to the normally open relay switch, which is over here. Then it comes off the switch through the trough again. So that's here to here, and then goes back to C. That completes that line of it. Now the next part is the umbrella switch, which is behind the cam. It's way back here, and that is a normally closed switch. So it goes from here to the normally closed switch, comes out of the normally closed switch, and goes to the normally open, which is down here of the cam switch. And then that shared that same common. That common goes back to C as we showed before. Now the last part of the motor circuit is the thermostat, which is a high temperature safety. Just in case the popcorn is popping and there's not enough popcorn to push the umbrella switch to get the motor started when it's in the popping cycle, the thermostat will close. And what that would do is you'll send voltage through the motor, through the thermostat switch, and back up to this terminal here. So this one is wired from the umbrella to the thermostat, out of the thermostat, completing the circuit over here to 3, which is up here. And that's all the wiring for the Popperette. The last thing I did was I put the cord in. So I just got a hot wire going to the one side of the fuse, and the neutral's just going through here, and the ground is on the frame. And the hot wire comes out of the fuse, then feeds this terminal, and the neutral, or common, goes through here and feeds this terminal. Well, I hope I was able to explain it a little bit. It's kind of tricky to explain this thing, but anyway, you should be able to follow what I did. And if you got any questions, just write me. I'll be more than happy to help anybody who wants to do one of these. But remember, I'm not an electrician, so if your house burns down, don't blame me.